Hi everyone, David Blakey here. This video is called Python String Slices. You may have watched the previous video, Python String Methods and String Slices, and realized by the end that we hadn't covered string slices, so that's what this video is for. Strings are a little like containers. And what is a container? Well, let's take a look in the Python interactive prompt. Container, traditional container, is something like a list. Here's looks like a 6-element list, my list. We have other containers actually. We have my tuple, which we could name anything we'd like, of course. My tuple is like a list, except that it's read-only. It's immutable. We'll talk about tuples a little bit later in the class. We have a third container called myDict. Well, it's not called myDict. It's called dictionary. And we're calling our dictionary myDict. Here are 3 containers that are available to us. They allow us to contain other objects. You can see my list contains, looks like 3 strings and 3 integers. The tuple, my tuple, contains 2 strings and 3 integers. And then we have a dictionary, which is a list of pairs. We'll get into that later, but you can see that the keys are strings and the values are integers. We'll get into that later. What we want to talk about now, though, is a string. If we were to have a 8 or so letter string, we're also sort of talking about a container. And how do we know that? Well, it's sort of interesting because if we wanted to take a subscript of a list, we could get the first element. This is one of the functions, the core features of a list. If we say mylist subscript 0, we'll get the first element. If we say mylist subscript 1, we'll get the second element. This would be true of a dictionary as well, and even true of a tuple as well, and even true of a dictionary. What's really interesting, though, is my string, that a string that we create, also is subscriptable. So here's the first letter of my string. Here's the 5th element of my string, which is the 5th letter within my string. So very much like a list, strings are subscriptable. Now, of course, lists can contain anything. We could have a string hello, we could have a number, we could have a floating point number, etc. There's 3-element list. If we said this list 2, the 3rd element, we get 3.5. If we say this list 0, we'll get a string. There's hello. With a string, though, it's always one element means one letter. So if we ask for the last element, for example, of my string, we'll get K. Now this works the same in any container, a list container, a tuple container, or a string, which acts like a container. We're not really going to call it a container, but we can say that it acts like a container, as if it was a container of a number of single characters. Now normally we're not really that interested in a single character of a string. Normally what we're interested in is something called a substring. A substring is a portion of a string, as you might guess. With my string, for example, perhaps we would just be interested in the first 5 characters of my string. We could pull out the first 5 characters by using something called a slice. We'll start at 0, and we'll end with 5, but that doesn't mean that we're getting the first, that we're including index 5, because what's my string 5? It's F. If we're only interested in A through E, we use something called a slice, but interestingly, we include an index, upper bound index, that is one above what we're actually looking for. Here's A, B, C, D, and E. You can see that what we got was 0, 1, 2, 3, and 4. The index 4 element is E. So then why, when we get a slice, do we use an upper bound that's 1 greater than the element that we want? 0 is the first element, 0 is A, and so it begins with A. But interestingly and also strangely, the upper bound, 5, is one above what we want. 0, 1, 2, 3, 4. And we specify 5, and we get 0 through 4. It's what we call a non-inclusive upper bound. Just something that you need to be familiar with when you're working with slices. The slices are going to have the same behavior with any type of container, including a list. So we'll look at this later, but if you had a list of, let's say, 5 integers, and you wanted to get, let's say, just the last 3, you could say my list 0, 1, 2, 3, 4, and then we're going to go one above, right? 0, 1, 2, 3, 4, and we're going to use the upper bound. So 3, 4, and 5. Just to clarify that, my list 4 is 5, right? I'm sure that's really clear to you. Let's try it again. A, B, C, and D. Let's say we're just interested in C and D. We're going to say my list 0, 1, 2 is C. My list 3 is D. And yet when we try to get a slice, we need to say 2 and 4. That is, the upper bound is non-inclusive. The upper bound is non-inclusive. Now this is something that's not terribly intuitive. If 2 is C and 3 is D, why do we go to 4? There is no index 4. Let's try to look for an index 4. There is none. Look, we get an exception, an index error exception, which says that the list index is out of range. That means that we used an index that the list doesn't currently represent. 0, 1, 2, 3. There's the last one, 3. If we specify 4, we're going to get an error. So why does this work? Strangely enough, why does this work? It's because the upper bound is non-inclusive. The upper bound is understood to be one greater than the desired element. And that's true of a string as well. So there's our string again. If we wanted to get the last 5 elements of this string, 0, 1, 2, 3, 4, 5, 6, we'll say my string 6, and then 7, 8, 9, 10, and we'll go to 11. So there's G, H, I, J, and K, the non-inclusive upper bound. Of course, one thing to understand about these sequences is when you want to specify a substring or even a portion of a list that goes past the last element or that includes the last element, we can simply not include the upper bound. So this is the same thing. 611 is the same as 6 with no upper bound. No upper bound simply means give me to the end. And that works the same way with lists, tuples. It's all the same. So 2 things we've learned so far. First is that the lower bound is inclusive and the upper bound is non-inclusive. Secondly, we've learned that a missing upper bound means that you can it'll take the substring straight to the end of the string. So we don't need to know the number, for example, of the last element or one above the last element. We can simply specify no upper bound. And one other thing we can do as well is specify no lower bound. So here's my string beginning as 0, where we could have put 0 right here. We didn't specify a lower bound. And then ending with the non-inclusive upper bound of element 3. Remember that my string 3 is D. We got everything up to D, but not including D when we specified the non-inclusive upper bound of index 3. So another thing, if you're new to computer science, you may be a little bit thrown by finding out that the first element is actually index 0. Second is index 1, 2, and here's the fourth element, index 3. So a couple of things to keep in mind. One is that indices begin at 0. First element is 0. The second is that in a slice, the lower bound is inclusive, and in a slice, the upper bound is non-inclusive, one higher. Another thing that we learned is that a missing lower bound means lower bound 0. And also, a missing upper bound means upper bound to the end. of the sequence, means to the end of the sequence. So here's your little quiz. I'll give you a second before I answer. What if my string is this? What do we get if we specify neither an upper nor a lower bound? The whole string. Now, what are we getting when we say that we get back the whole string? We are saying that a slice actually returns a new string. So if we go back to our trusty program, delete our last lesson's code, and say my string equals hello world, and we want to take a substring of that, we can say object, sentence object equals my string, and let's do a slice that includes world. Can you tell me what that would be? 0, 1, 2, 3, 4, 5, 6. So beginning with lower bound 6, 7, 8, 9, 10. Oh, that was the phone, wasn't it? 6, 7, 8, 9, 10, and not including 10, we'll go up to 11. And then we'll print sentence object. Why do I say sentence object? I mean, it's the object in the sentence. Let's save that and see what we get. World. Perfect. That's exactly what we wanted. If we wanted to get it up through the end, we'd have no upper bound, obviously. We'd get world. But the point I want to make with this is, what is sentence object? What sort of object is it? What type of object is it, really? I'm sure you could guess. Oops. Type stir. In other words, sentence object is a string. And what else? We can also say that a string slice returns a string object.